All right, so when we left off, I had just shown you this amazing picture of throwing paper in the air because you just can't even, because there's just too much going on, and this is that dreaded merge conflict. This is the worst part about using version control, is that once in a while, you are expected to deal with a conflict where you and your collaborator, which may be yourself, have made a change to the same file in a slightly different way, and it doesn't know what to do with it, and it says, fix it. And I'm going to show you what this looks like. We're going to make this happen, and we're going to do one of these in a few minutes. This is what they look like. There will be a spot and a breaker, and it will say, okay, look, you wrote the stuff in purple, and the stuff in yellow is what it has on GitHub. Those don't match. What do you want me to do about it? And then you have to go, well, okay, obviously, I'm going to leave my supervisor's grammar changes because otherwise he'll yell at me. I'll just delete my changes and merge them together. Or, ooh, whoa, that's okay. Something has happened. There is a sort of a funny philosophy in the use of Git, which says there is the burn it all down method, which is sometimes you've broken it so irreparably that the only option is to copy all the files out of the repository, delete it completely, purge and salt the earth, and start again. Usually you don't want that to happen, but especially when you're new to this project and this way of thinking, it does happen. And sometimes you just have to start over. But your files are always safe, and that's the important thing. So in summary, we have local, that is your computer. We have GitHub, that is the cloud, that is somebody else's computer. On the left-hand side, we have a tracking of which files have been modified, how they've been modified, and you have made changes. And on the right-hand side, we have the version that traditionally we don't make changes in the cloud. It is simply a reference record for us to point to say, okay, that is our history. If we ever need to make a change and go back, it has been saved. All right, some little knowledge checks, just sort of to get our brains back in it. You've all had coffee, you're all awake now, which is wonderful. But which of these is untrue about Git and GitHub? Does it allow you to view and retrieve older snapshots? Well, I didn't emphasize that. But if you look, you see all those little dots? You can jump to that moment in time anytime you want. That is the point of this, is to allow you to do that. So absolutely, it allows you to view and retrieve older snapshots. Does it automatically snapshot your work every 2 minutes? Let's leave that one. Does it provide transparency on who did what to what and when and where and why? Oh yeah, that's the whole point. Every time you commit, you're saying, hey, I'm committed. If I'm working with you and I commit and then you grab the repo, you can be like, well, Wesley made the last change. He's the one who broke the code. Blame him. And there's literally a function in Git called blame. Git blame. Who do I blame for this thing that just happened? Not me, it's someone else. So check. And it acts as a way of backing up. Yes, it does. That's the primary reason we want to use it. The whole bit about reproducibility is kind of a bonus. Number 2, though, it does not automatically snapshot your work. It does not auto-save. It does not auto-commit. It makes you be part of the process, which can be sort of terrifying at first when you're used to a world where Word has saved your work for how many years now? In my lifetime, I remember when they turned on that feature, but it's been decades since Word didn't just save your work every 30 seconds while you were typing. This does not do that. Is GitHub the software you use locally on your laptop? Yes or no? It is not. GitHub is the trademarked registered name of the software company, now purchased by Microsoft, that runs a cloud hosting service to let you do remote backups. Git, G-I-T, is the name of the software that we're running. You change two files, notes.txt and eda.ipython notebook. You only want to commit changes to the Python notebook to the version control, not your rough notes. Which command allows you to do that? Now, this was in that picture before the coffee break. You probably missed it. That's okay. When you have files which are changed, but not put in the staging area, the function that moves them into the staging area is the add function. You add them in, then you commit them, then you push and pull. That's your flow, your workflow. At a minimum, how often should you push your work to GitHub? Well, this is up to you. So I don't know that there's a right answer to this. When I'm working on something, I don't usually push it to GitHub all that often, unless I'm building slides and I want to be able to view them on the internet and check that they're working properly. So most of the time, I do it every day, once a work session. Because you don't want to do that thing where you hop to another computer to go work on a project you've been working on and not have all of the latest changes available to you to pull down. So you think about it, when you leave the office, push to GitHub. When you leave your home, if you've been working overnight, push to GitHub. It's always just making sure you have your files available to you. So I do work session. Some people do every 30 minutes while they're doing the work, just in case, again, a phantom laptop smasher bursts through the window in the middle of your work session. You really want to make sure that work is saved. But most of the time I do it kind of like once or twice a day. All right. You try and push your most recent commit. You've made some changes, you've added them into the staging, you've committed them. You're going to try and push it. It fails because it says that the remote contains work that you have locally. What do you do next? Well, actually, there's a missing word. This should say you don't have locally. That's the, I'm working with someone else. They've done a change in the time between I synced to our joint collaborative space. And when I try to do that commit, to do this properly, then you have to pull their changes down, merge them in with your changes, save that by committing the end result, and then you're allowed to push it back up. It's sort of paranoid in what it will and will not let you do, because it says, do you know what you're doing? You really shouldn't be overwriting that file. Your collaborator did that. Do you know what they did? Have you looked at it yet? And you're like, oh, fine. And you pull it down. Final thing, you pull changes that you don't have. You get a message, auto merge failed, the dreaded merge conflict. What do? Well, you can't just push it. You can't just force pull it. You're going to break everything if you do that. If you see a merge conflict, it's a sign that there is two different sets of work for the same file. And if you don't know what that two different sets is, you definitely just need to slow down and look at it and go, okay, what is that? Because maybe your supervisor was super ambitious and got up at 3 a.m. and made some fundamental changes to the script that you're running. And if you overwrite that, they're not going to be too happy with you. Or maybe you forgot to pull those changes you did last night before you started for the day, and you've now broken things. You have to open the files, go through, figure out what went wrong, and fix it. And then you can proceed with your life. So there are a bunch of additional resources. This is just scraping the surface, folks. Like, I am not going to teach you to be a Git expert in 2 hours, but I would like you to be able to use it. And if you're willing to use it and you just get started, there is a wealth of material out there. You can learn more on your own. And like I said in the start of the day, there are the carpentries. They do these wonderful 2-day workshops on ideas that are connected to this. You can learn. Now that you know there is something out there to learn, you can choose to go down this path and learn more. All right, so what we're going to do next is actually work a demo. We're going to use Rstudio. We're going to work a demo. We're going to try this out. So the first thing I need you all to do to be able to do this is go to the GitHub for me. So open up a web browser and go to my GitHub, my public facing GitHub with my public repositories. And in those are one right at the top, which I pushed up last night to make it ready for today, called r-cube. It is a very, very simple thing.
Do you have the link shared?
Sorry?
The link shared?
No, I don't actually. It's github.com and then just my name. Or if you Google GitHub Wesley Burr, it will pop up. It is indexed on GitHub. Once you're there, just go to my repositories. Excuse me. And that top one, once you click on it, there will be a button that will allow you to use the template. Click that, and if you've never used GitHub before and you created your account for today's workshop, that will create your own first repository in your personal account. Are folks getting it? Once you click that button, is it creating it for you in your own account?
Yeah, what's my name?
So name it whatever you want. You can leave it as the same. So you're going to get an interface which will look like this. So if I click use the template, create a new repository, and it'll bring up this interface to say, what do you want to call this? So this is exciting. This is your first repository. You can call it whatever you like, or you could leave the name the same as what I had it. So RQ, whatever you wanted to call it, demo repo for today's workshop. And you're ready to create. Now I'm logged in as this demo account. So this is the very first repository in this demo account's setup. And the only repository then that shows up is RQ. And it will bring up this as the default interface. All right, let me know if you don't get that far. That's that you need to have this so we can switch back over to Rstudio and actually do the next steps. Poke around. If you've never used GitHub before, take a look at the files in this repository. There are only 3 of them. One of them is called license. It's the actual license for this repository. This is open source software, so we traditionally do assign licenses. This is public facing. Anybody can grab this and use it. What license would you like to license this usage under? And I usually do something like an MIT license or a GPL3 license or CC BY. I'm just like, sure, have at it. Use it wherever you want. All of my research input software, the open source software that I write statistical algorithms and R packages, is all GPL, which just is basically non-commercial unless they pay. Click on cube.r. I assume most of you have written R code in the past. So click on cube.r. It is the simplest possible function you can imagine. It's also wrong. So this is what we're going to do today. We have made what we are very, very proud of. We've made a little function in R. We're super proud of our work. It doesn't actually cube the number. It squares the number because we typoed it. All right, now technically you can do the whole work in GitHub, but we're going to do something first. So now you set up Rstudio so it can talk to GitHub. You have a repository on GitHub. Now let's get that copy down on our computers. So switch back over to Rstudio. But before you do that, go back to RQ, and it will now show you a slightly different button. Instead of template, it now says code. Under code, there is a command there under the code and the choice of SSH. This is specifically the information you need to be able to make a local copy of this thing for you to be able to edit and use on your computer. So you're in the RCube interface, ties meaning RCube. So this is your account, RCube. You're in here, you can see these 3 files. There's a code button there. And then under this, choose the SSH option. And we are ready to make a local copy. Click this little copy icon. I now have that link. I'm now ready to switch over to Rstudio. All right, I'm in Rstudio. It's all blank. There's nothing here. I have nothing set up whatsoever. Now, a little plug. Many of you probably don't use Rstudio projects because you don't have to. They are actually remarkably useful things for the promotion of reproducible research habits because they force you to put your shit in one spot and stop just like having a directory of random projects with everything strewn all over the place. So if you have a project, it puts everything in one directory and it organizes it, and it lets you set it up to have an attached repo and be able to push and pull from GitHub quite smoothly. That's what I'm going to do next. Go to File. Go to File. Go to New Project. Don't bother saving unless you were working on something earlier today. And then one of the options is to do this via version control. And this is the one we're going to choose. So check it out from version control. And then one of the options is to do Git. And then paste in the information that you had copied from GitHub. And then you can give it a name. It will default to the name. If you change this, it kind of messes things up sometimes. So you usually just leave the same name. And where do you want to create it as a subdirectory of? So the default is tilde, which is just like your home directory. You can have it inside a source directory or a projects directory or I don't know how you organize your computer. I hope you organize your computer. Teaching first years has made me despair about humanity in general because they literally will have 9,000 files in their downloads directory, and that is their file organizational system. And then they're like, but I can't find it. I'm like, well, no kidding, because you just piled it all up and then lit it on fire. Sorry. I'm from an era of computing when if you didn't use files and directories properly, nothing worked. So once you're ready, click Create. As a note, you can actually run different versions of R. That was the final module for this workshop, which I'm probably not going to get to today, was about how we can work with some of that. But create this project. It may come up and say, I've never connected to GitHub before. Are you sure you trust this? You look at it and you're like, github.com. Yeah, okay, that looks like that's my SSH key. That's my SHA thing. I typed yes, and it runs a command. So Illich, if you're getting that Git was not detected on the system path, did anybody else get that? Okay, so for those of you who are hitting that, Mac, Sky, what are you using today? Windows. Our tools for you, and Xcode command line interface tools, both of you. When you would first install Rstudio, it would have popped up a message and said, hey, do you want to make sure this is installed? And you probably just said no. So if you go back and you do it, and I can help you both at lunchtime do that, it will install it and it will work. So for Illich, if you're on Windows, you will need R tools. And so that's like Google download our tools for Windows. And there's a set of links. You just have to be careful. There's a version for R4.3, a version for R4.2, a version for R4.1. Make sure you use the one that goes with whatever version of R you have. And it comes with this set of software. Now, I'm actually now in a project. It doesn't look much different, but over here, I'm now in the R-cube directory, and you'll notice that I have files, cube.r, license, readme.md, the 3 files that were on the cloud. I also have a .r project file that's describing the project that I just started. Up here in the top right-hand corner, there's a little drop-down interface, which indicates your project status. And so I'm currently on the R-cube project. You can have multiple projects active, and it lets you change everything all at once if you want to switch to a different project that does different things. I use projects for course preparation work. So I keep my kind of like teaching lectures and that sort of thing separate from my research work, where I have very different demands on my fonts and the interface and all the rest of it. Now that we've done that, let's pretend to be a collaborator. Okay, so switch back over to GitHub. We're here, we're in GitHub. Now, we don't have a second computer today to pretend to be a collaborator. You can edit files directly in GitHub. So we're going to do that. We're going to pretend to be a collaborator. We're going to come along. You said, hey, I'm really proud of this work I've done. Here's my project. Here's the function I wrote, which is for our research. And your collaborator's like, hey, dumbass, that's a square, not a cube. What are you doing? So let's be that collaborator. Click on this cube.r function right here. And then manually, we're going to edit it right in GitHub. Okay? Click the little edit pencil. And you go in and you're like, look, if you want a cube, as any child knows, that's x times x times x. As soon as you made that change, we're going to commit it. So when you're editing in a GitHub, it's like, I hope you know what you're doing. We're going to add and commit all in one action. So it's going to commit. You have to put a message. I fixed your silly error, you silly, silly person. And then I commit those changes directly to the main branch. So now if I go back to here, you will notice there's now 2 commits, not 1, on the repository in the cloud. And if you click that link, you can actually see them. See, there was the initial commit where I merged it over and I got this copy of this repository for myself. And then there's the update. And it even has my little message that I put in there. There is a running joke among people who use Git about how bad our commit messages are and how we're all going to do better sometime. And usually it's a series of swear words because it's 3 in the morning and nothing is working. And you're just like this stupid, and you're committing messages after messages until you finally get it to work. Nominally, those commit messages are part of the public record forever. And I actually saw an amazing paper at an IEEE conference where they actually did semantic analysis on the content of the messages and how often particular swear words are used. It was amazing. Basically, we all understand working with computers is amazing and has let us do things we would never have dreamed of a generation ago, but also they're really, really annoying. And they don't do what you want, they do what you told them to do, which is even more frustrating because you know it's your own fault. All right, so this is fixed there. Switch back over. Now, the channel, to get a dreaded merge conflict, to get this happening, we need it to conflict. So we have to pretend we don't know that that's changed in the cloud. I grabbed it this morning, your collaborator grabbed it this morning, they just pushed their change first. So you just got a coffee, you came back, you sat down and you're like, all right, I'm gonna do some code. You click on cube.r and you look at it and you're like, okay, how tired was I last night? Why does that say x squared? Obviously, I meant x cubed. Now, before you change anything and save it, click on this little interface up here. Now watch this. Change the cube and then save the file. Did you see it pop up? This is that area of these are all the files that have been changed. These are all the files that can be added. Remember, we add into the staging directory and then we commit to permanency from there. That's all the files that have changed since the last time we committed locally, which we've never done. So now I check this button to say, okay, and then I commit it. It pops up and it's like, okay, you changed x squared to x cubed. That's what you wanted to do, right? And I'm like, fixing my error. I was really tired. Now, it's probably going to pop up and give you this error message. For those of you who have never used Git before on this particular computer. It sounds scary. It's totally not. It just says, please tell me who you are. You never actually set up an identity here. So if I want to know who made this change in the future, you haven't identified yourself yet. You only have to ever do this once on any given computer. So what you can do is grab these 2 lines of code, copy them. There is an interface that will let us do it. And then back over here, I'm just going to dump them in a text file for a second. The second tab over, this terminal, you can run these commands if you want. And so I'll do this and I'll say, and the email address was ties.meeting.2023@gmail.com. And then, now this is, if you are going to collaborate with yourself, this is where you can actually anticipate problems into the future. I can just put my name there. But then any commit that comes from this computer is just going to be tagged with my name. If you have multiple computers, it might make sense to track which computer it came from. Then you'll be like, oh, right, I did that one while I was real tired at 3 in the morning because I had insomnia because I was at home. And so I'm going to say Wesley on the server. Once I've done that, if I then recommit, it's going to let me accept this. Fixing my error, I was really tired. And it says, okay, 1 file changed, 1 insertion, 1 deletion. I close. It's no longer in this top interface because it hasn't changed since the last time that I committed. And now I have a copy on my local computer, which has a commit that fixes the bug. I have a copy on GitHub that has a commit that fixes the bug, but those happened in parallel. And to be obtuse, my change is not the same as the other change. All right, this is where you're like, okay, it's time for lunch. I should push it to the cloud so that my collaborators know that I fixed this bug. And you get an error. And it's sort of a scary error because it says rejected, failed to push. What does it say? The remote contains work you don't have. That reference copy on GitHub contains work that I hadn't taken into account when I last started doing work. To fix this, I have to integrate the remote changes. I have to pull them so I'm synced up before I'm allowed to then push back over top. And it always just kind of picks the remote one as being the one that wins in any sort of fight. So now I try and pull. And this errors, we have divergent branches and need to specify how to do it. And so do we merge it, rebase it, or branch it? It's like, you just messed me up and I don't know what to do. You have to tell me what my default action is supposed to be. Now, this is the moment where some of you are going, I'm never going to use this. This is terrifying. What is happening here? If you use Git in one and only one way, which is I do work, I commit it, I push it, and you just use it as a backup, you will never hit any of these problems. These problems happen when you get conflicts between two different sources. Having said that, as scary as this is, as chaotic as it seems, there are tools to make it easier, and it does unlock a superpower for you that is worth the struggle. I know it may seem like it's not, and I may be, I'm somebody who obviously believes strongly in all this, blah, blah, blah. Honestly, all it takes is you hitting one of those cases we talked about in the first set of slides for you to go, oh man, it would be nice if I just hadn't backed myself into a corner because now I'm stuck and nothing works. So these are things we do, even though they're hard, because they set us up for success later. So what we're going to do is we're going to run this one command here in the same way we ran these other two commands. Pull.rebase and false. Sorry, this one has to be done in the rq directory. So it was cd to that directory, run that command that I just copy pasted. Now let me try and pull down. And this is where we get now our merge conflict, because it says, hey, hold on. I tried to pull what was in the cloud. I tried to pull what you said was the latest copy, but you've gone and changed a file that they also changed, and I don't know what to do with what you just did. So this automatic merge failed. Please fix it and then commit the result. Close the message. You'll notice now, this is now popping back up, and it's got this U for unresolved. This is what the file actually looks like right here, right now. And the first time you see one of these, you're like, what on earth is going on there? Remember the slide. It put in these 3 lines for us. It said, look, I've got a copy that says X cubed. That's your copy. But I've got a copy from the cloud, and it said X times X times X. Everything between the set of arrows, figure it out. It is Sheldon from the Big Bang Theory going, paper in the air. I give up. I don't know what's wrong here. Fix it. Because I don't know how to take these 2 lines and resolve the problem. Now, most of the time, we're people. I just look at that like, oh, of course. Okay, John went on and he did his change earlier and I didn't know about it. I didn't grab it. We've both done the same thing. All right, fine. Depending on who is the higher status academic, you leave your supervisor's horrible code alone and you delete yours, or vice versa. We do that. We save. And then we commit that I have just fixed the problem, merge resolution, and then we push it back up before anybody else mucks about with it. So I commit and I say, all right, fix the merge problem to simultaneous changes. Actually, sorry, I didn't actually add it. And then we're good to push. Okay, why is it not committing my merge? Sorry, one second. I apologize. I don't see why it's being silly. Fix the merge, branches ahead of origin main by one commit. Merge corrected. There we go. And then we've pushed it back up. So I figured out the problem. The reason was in the choice of which one to keep, I kept the version that I had done. And so locally, there was actually no change from the last time I committed, and it was very confused by that. Normally, you're merging two sets of code, and you kind of like you end up with at least one change from what it was. So adding the comment in there was enough to do it. If you go back over to GitHub and you go to your repositories and you click in here, you will now see there are 4 commits. The initial, the update we did as the collaborator, the error fix, and making sure the merge had happened between the two. And now remote and local are talking the same language again. So again, this only happens if you collaborate with more than one computer. If you only ever have your laptop and GitHub, and you want to just commit regularly and push to GitHub, and that's all you ever do, it is a very effective backup system and version tracker. Let's say you did this, you thought it was fixed, you went away on vacation, you came back, and you go to run the code and it no longer works. Then you can always go in, and if you click on any of these commit details, you can always step back in time and browse the repository at that moment in time. So if I click here, this gets me the repository as it was when I started the project with x squared. If I go back and I jump to here, I can then see my collaborators x times x times x. If I then go back twice more and I go to here, I can see the final version. So when it comes to code, you don't want multiple copies of the function floating around. You don't want multiple copies of an analysis script floating around, because then which one was it? Did you run the one with the bug in it and then try and submit that to the journal? You want one reference canon copy of a script, but you also want to track the changes. And this is how we do it. And this, done right, carefully built into your workflow, will help you from making all those mistakes and problems I talked about in the first part of the workshop, and will give you eventually access to a superpower in terms of how you collaborate and how you work. Quick check. How many of you have ever used a software platform? It's all a website called Overleaf. Any of you? Overleaf uses Git on the back end. If you go into Overleaf and you track the changes on a text document that you've been writing in Overleaf with collaborators, in the history, every single one of those histories is an SHA hash and is a Git commit. It actually uses Git to track the changes in your LaTeX document. It just puts a really beautiful interface over the top of it so you don't see any of that mess. But every time there's a change, it does a commit, and you can always step back in time and see what that is. In Overleaf, if you go to the left-hand side, you can actually see the Git repository and pull directly from it and push directly from it. I have a collaborator who refuses to use the Overleaf interface. He hates it. He's an old school Emacs guy. It's like, I'm only writing my LaTeX documents in Emacs, damn it. And so he will pull the repo down from Overleaf, do all of his edits locally, commit, and then push it right back up. So yes, you can interface directly to and from Overleaf from Git.
It will create a repository of its own, and then I will have to push to that repository, or it's like.
I don't think it lets you push direct. You have to create it there, even as just like an empty stub, and then you can push and pull from there. But chat with me at lunch. I have gotten it to work. It's just I always create one in Overleaf first, and then I go from there. All right, so what time is it? It's 11:30. So that was our demonstration of how you do that. All of that steps was recorded for those that want to maybe go back over it. I have a little bit more material. As a reminder, we do have the program is on EasyChair. But this is not my computer, so it doesn't autocomplete. But the program and all of the information for today and for the rest of the week are on our Smart program. And I can't. Okay, we're just going to leave that. Sorry. I sent the link out by email anyway, so the program is there, and I'll throw it up later. So with the time I have left, which isn't all that long because we've got lunch coming up soon, I want to talk to you about one more thing that can go wrong and one more thing that you can do to deal with it. And that is computers change. Have any of you been doing this for long enough that you have taken a script that you know full well worked and you go to run it and it's been, let's say, 6 months? And in the time between then and now, you've updated Rstudio, you've updated R, you've updated a package you used in that script, and nothing makes sense anymore? This is the final thing. When you talk about computation, it is a moving target. Just because it ran on your computer today is not enough information for someone to take your paper and figure out how to make it work tomorrow. Because software changes. Sorry, there was a question. Thank you. So Castle's letting us know. It looks like using the Git with Overleaf requires a paid subscription now. So if you don't have a paid subscription, you won't be able to use that feature. I pay for it, so that's why I thought it was still a thing. Some places have institutional licenses. I think Coast might actually. So if you're covered by your institution, then you're covered and everything's good. Thank you for that, though. That's a very good point. All right. Shippable and shareable computational environments. So to be able to reproduce a result computationally, we need more than just the data and the code. What we actually need is the computer you ran it on. But we can't just take your laptop and archive it and put the laptop in a safe every time you're done an analysis. And also, you want it to be able to run on someone else's computer. So we need the software that ran the code in the versions that it ran on, and sometimes even the operating system that it ran on for some very specific stuff. So programming language, what programming language was it? What version of that programming language was it? Whether it was R or Python or Julia. Were you using packages in R or Python to do stuff? Python is terrifying because their packages change so rapidly with so little regard for breaking old code that my conservative estimate is that 85% of all tutorials on the internet written by someone trying to teach you how to use Python for machine learning will not run if you try to run them today. Every time TensorFlow updates, they break something. They have no regard whatsoever for backwards compatibility. Our packages also do this. The tidyverse is the worst offender, but they at least try because CRAN insists that they try. And that's one of the good things CRAN does is like, did you just break all the APIs? Because the base R packages, the stuff that comes with R, 20-year-old code will run in that. That is unheard of in Python and Julia. Okay. Julia is much better. They've got a much better system, but they're moving so fast, they're changing, right? We need the versions you ran, the extra pieces of software you used, the legacy code you used to take that file that came off that instrument your PI bought back in 1986 and is still getting their last bottom dollar of value out of it. It exports in some sort of weird ass format. How did you get that data into your computer? I need to know. All of that is necessary, or I can't reproduce exactly what you did. Now, there are many ways to do this. As I said, you can literally take your laptop, turn it off, put it in a safe. Okay, now it's reproducible by pulling that laptop out of the safe, assuming the laptop starts up. We don't want to do that. We want to basically bundle things together. So you may have heard some of these words. Some of you may have even used them. Wonderful if you have. There are virtual environments. So renv, conda, mini conda, and virtual n for Python. Those, what they do is they create a virtual environment and they put copies of the packages in there. Containerization goes one step forward and goes, no, I need the operating system too. You can't just give me the packages. I got to know what operating system it ran on. And a full-blown virtual machine says, okay, I want the hardware specified that it ran on too. Hardware and the operating system and the packages, that's the level that I need. So the lowest level is the virtual machine. It's usually overkill. For the majority of what you folks are working on, just the environment is enough. But if you're working on, cryptography code or something that's extremely computationally demanding and you're using all kinds of weird linear algebra tricks, you may need to go all the way to a virtual machine to make your results reproducible. Because every different architecture of computers does their numbers a little bit differently. And they compute their random numbers differently as well. So virtual environments, that's what I'm going to talk about with you for the remaining amount of time. What this lets you do is have multiple different versions of your programming environment. In our case, it's R on your computer. And each of them can have their own set of copies of packages, which are fixed at whatever number you last had them at. Because I've certainly done this myself. Something's working, everything's great. I start up Rstudio and it says, I want to update the tidyverse. I let it update the tidyverse. Then it wants to update Rlang. Then it wants to update this other thing. By the time I've done half an hour of updates, and then I go to run something and it doesn't do what it did yesterday because I just changed the versions. Virtual environments let you fix those versions in place and say, okay, for this analysis, which is working as of today, here are the packages that you need to get it to work because I know they work with these versions. So much of this actually came from the renv website, which is a guy named Kevin Uche who wrote all of it. The general workflow is you'll need this package installed. And then once you have it installed and you've created a project in Rstudio, you run the command initialize init, renv init. And that will make an empty directory, which is that project's local set of libraries. Then just do whatever you need to do, install whatever packages you normally would be using. Everything's great. You're getting all set up. This is done at the start of the project. And then you can snapshot that. If you update things when everything's working, snapshot it again. Or if it doesn't, say you are working, like you're just doing a day-to-day thing, you do an update to the packages. If it stops working, this is a snapshot that lets you step back in time to when it was working. Because again, Like I have this rule for myself. I never update R packages between September 7th and December 20th. Because if I do, it will break something I use in my teaching. And I just don't have time to try and figure out how to explain to 700 first years what just happened. So I tell them all, install all the packages on the first day of class. Do not touch that until Christmas. I don't care if there are updates. Don't say yes. We know this version works. We're all using the same version. If you change anything, stuff may break. I had students this summer who updated their Rstudio and then they could no longer knit in the middle of the semester when we're like have assignments due every week and it no longer work with the new work. So stuff does break. You may not have experienced it yourself, but teaching 700 people, you see 700 different computers worth of like ways things can break, and you appreciate that. So these are the steps. So it's like Git, but it's not saving the versions of your files. It's not doing version control. It's encapsulating the environment in which your code ran and was successful. And this is nice because you can share these with other people. These are the projects it actually uses. It creates an R profile, it creates a lock file, an activation, a private library, and some settings. And then if you're doing this and you're also using Git to track stuff, you should take these 3 files and they should be checked in, added, committed, and version tracked so that if you make a change, GitHub copy knows about it and you can always step it back if something has gone wrong. Don't just create these, not track them. Then if anything changes there, you don't know what changed. These are sort of tracking your history. So it's a package. You can install it. Do install.packages renv. And if you let that run, it will install. Excuse me. And then you can use this to collaborate. People don't think about this, but if I'm collaborating with you and I say, oh yeah, we're using R, and you're like, oh great, I have R installed on my computer. What version? Do you have all the same libraries I have? One of the most common sources of frustration when working with someone else is you have R code that you know works perfectly well on your computer. Maybe you've even been version controlling it, you've been tracking it, but nothing works when your collaborator tries to grab it. What's wrong? What's different? These let you track exact versions so that they can sync up with you and make sure that they are running the same thing on the same environment in the same way. And I have this with my students. Anytime some of them are doing stuff locally, half the time it won't run on my system because we've desynced our package versions and all of a sudden something just doesn't work and doesn't transfer. Again, this is work. I know it's work. I know you are all busy and your brains are full and your capacity for adding things to your work life is fairly limited. This is the pain now to prevent pain later approach here is what we're trying to do is encourage you to set up parts of your workflow, even though it takes effort, because they let you deal with or eliminate worse pain points in your future. And you kind of have to take my word for it, basically, because I've been there and done that, and I've experienced this pain from your point of view and where you've been. And it's horrible. And I would do almost anything, any amount of work to make sure I don't run into those problems again. That's, it is worth the extra effort, but sometimes you have to experience the horribleness of a failure before you realize why it's so valuable. So you open a copy of the project if you wanted to use this, your collaborator does it, they clone a project from GitHub, they open Rstudio and open up that project, and then they run that line of code, which takes the local library with all of its versions, sets it up on this new computer, and now you are synced up with exactly the same package versions and the same R version and the same everything. So the code that worked yesterday on that computer should work today on this computer. So I didn't actually leave enough time to do this. We can do this if you would like. You could actually set it up, but I assumed we were going to kind of be near the end of our available time by the time I got to this. So the use this template button, I didn't actually set up that repo to do that. So questions. I know I've been talking a lot at you and I've tried to stop and check in, but questions, thoughts on all of this. How overwhelming does it seem to those of you who aren't R programmers? You feel like you could do something? Doesn't it, again, from what I said at the start, one change is enough. The journey of 1,000 miles and all those Zen cones, right? Like how do we change? We make one change at a time. So things that you can change. Just start using projects in RStudio. Nothing else. Just if you're in RStudio and you're doing stuff, use the project environment. Force yourself to divide your work because the project encapsulates things. Maybe the next step from that is figuring out how to use GitHub. Just for yourself. It's just a way of backing up your code that doesn't rely on Google or Microsoft or the quality of a horrible $5 USB key you bought off Amazon and works. Get you that backup. If you're working on a thesis, put your thesis into Git so that all those files for your thesis have versioning. Because I have opened up papers that I thought were different files. I opened up a file like that's the copy and slashed and burned, only to later realize that was the original version of the file. And now I have permanently lost writing that I didn't have backed up anywhere else. And like the second or third time you do that to yourself, you start to be like, I need a better system. I need to force myself to check this all into a Git repo before I start slashing and burning, because I think I know what I'm doing, but how much coffee have I actually had this morning? So anyone thoughts?
So I think you said before that GitHub can't store the data, just the code that runs on the data. So you have a data file, say CSV, and you have to call it in order to run the code on that data. So this GitHub will have the code, but not data.
So when you say CSV, you can totally check that in. CSVs are ASCII text. And so you can add those to your repo, no problem. But if you're dealing with, say, satellite remote sensing, that John here uses, those files are in the gigabytes. The rule is nothing over 100 megs should be checked into a Git repo. But if you're talking about, you have some field measurements, it's maybe like 25 kilobytes in CSV, yeah, throw it in there. That's basically code. It's a small ASCII text file. But yes, the next lesson in this kind of process of dealing with this is, okay, my data is too big. I can't do that. Or my simulation results are on the order of 50 gigabytes of data. What do I do with that? We don't have a good answer for that. And what we usually do is we just accept that you only have one canonical version of that data. And you store it there, and then you store it on an external drive or on the cloud. And you do something called hashing, which is where you check the binary structure of that file, and you can scan it and detect whether it's changed or not. So you scan it and you save the result of that hash. And then the next time you want to do it, or you check with a collaborator, or like, here's the data, you can have them also scan it. And if you get the same hash, it's binarily, that's not a word. It has binary identical structure. And that's all we can do, unfortunately. Once you get into the big files, like the outputs of global climate simulations or satellite remote sensing data, we're talking gigabytes upon gigabytes of files. You can't version control that. Nor should you, because it's not supposed to be changing. If it's changing, there's something weird going on, right?
The analysis changes.
Yeah, and that's where you have to like source, analysis, output versions. And you always keep a canonical, original, this is the raw data I got from source X, here's how I got it, Here are the scripts I used to download it off the NASA website, wherever you got it, and then you never touch it again. And just doing that, if that is the only lesson you take away from today, I will consider it a success. Your data comes down, and that original raw data is sacrosanct. You do not touch it. You do not modify it. You definitely don't open it up in fucking Excel, because it will break it for you. Half or more of all genomics literature is wrong because Excel converted genomics tags for DNA into dates. How many billions of dollars of research was that, where the journal articles are wrong because they used Excel and it broke some of the DNA tags, and then their analysis of sequences and so on broke. So that's the rule. You take that away today, I am ecstatic. Your raw data comes down, and that original file never gets modified, ever. You want to open it up and do stuff? Great, save it as another version. Lovely. But that original version never gets touched. Because if you do anything to that, we don't know what you did. And I can no longer trust your research 100% because I don't know what you did to that data. And for those of you in the environmental sciences, especially, your data is your work product most of the time. You went out in the field, you were in a boat for like a day and a half gathering those fish, right? You were in the lab for a year doing whatever it was you did. That is your scientific contribution. That piece of raw data is perfect in its form. It has to be saved. And yes, of course, we have to go in and go, okay, well, that was no wire, that was no wire, whatever. But we save that work. And we save the second version of the data. We say, okay, we're starting analysis from here, but if you ever want to check our work and trust what we did, here's the steps. Here's what we did to take the raw files from this horrible instrument that we've been using for a decade and turn them into something useful. But they can see and check what you did. And this is one of those things I wish I could take every single incoming grad student on the first day of grad school and take them and shake them a little bit. Be like, you are never allowed to manipulate your raw data. Because people don't think of it as manipulation. They're like, I was just opening up Excel to take a look at it. Yeah, but you saved it. And that means Excel did stuff that you didn't intend, and you have no control over that whatsoever. What if you open up an Excel and you're in Windows and you accidentally drag drop some cells? I am never going to be able to tell that, ever. Or you open it up and you went in and you tweaked a couple of numbers. I can't tell that. I'm not accusing any of you of research fraud, heaven forbid. But there are people out there who do this. They open up raw files and they tweak the data before they ever start. Or they do a whole cycle where they come back again and tweak it. And they pretend that was they measured it. Sorry, you got me ranting. This guy is great at that. This guy has 5 or 6 years of experience of triggering my rants.
I guess.
You and your classmates used to have a habit of being like, we don't feel like learning today. How do we get less on a rant? Yeah. Okay, thoughts, folks? Ideas? Do you feel like you learned something useful today?
Oh, this is more of a debugging question. I'm asking it just in case anyone else has encountered this. It looked like maybe they did in the chat on Zoom, but I don't have access to the chat because I just joined the Zoom. So you were saying that like as a Windows user, I should install RTools and everything. I already have RTools on my computer. I still can't find the Git like executive. Do I have to install Git separately as well?
You shouldn't have to.
Okay.
It may be the sequence. If you installed Rstudio after, or like before you installed RTools, it may not be finding it. I can help you. The usual sequence of install R tools, install Rstudio is usually enough. Take care of it for you. So I'll take a look at lunch and see if we can figure it out. I'll put messages up in the Discord for any further notes. So just as a general note about the week for those who are staying. So today is obviously day 1. This afternoon, we're going to be learning about Google Earth Engine from Jumi. She spiked a fever over the weekend and couldn't fly, so she's going to be doing it over Zoom with us. So she'll be present with us shortly after lunch. Those of you who are staying for the week, make sure you've fully checked in and I know that you're here and you've got your goodies and your map and the rest of all that good stuff. And we are going to be having lunch in the next building over. which is the big yellow building. There's a cafeteria there where we can go for lunch. And then all of our sessions will be back in this room. There is power scattered through the room because we're here all day, every day. And so feel free to bring your chargers because I know how, like, my laptop lasts about 3.5 hours and then I'm about done. And so if you want to plug in, I tried to set it up so everybody could do that. For everybody who's online, if there's any sort of feedback on the sound or anything to do with it coming through to you all remotely, please let me know. You know, we're trying to keep an eye on it and make sure that everybody can hear, but if there's any problems, please do let me know. And other than that, let's take a break from lunch or for lunch, and we will be back for our session this afternoon with Jumi. And I hope you can all join us then.